So let's look at the graph of an absolute value function in its most basic form. So you're going to graph some points and see how they connect together with the absolute value function. I'm going to use x from -6 up to +6. So in terms of how we calculate our y values, what we're doing is we're taking the absolute value of each of these inputs. So I want to find all of these absolute values. Oops. Absolute value. Okay. So simplifying these down, absolute value of -6 will be +6. We'll have +4, +2, 0, +2, +4, +6. So let's start graphing these values. So I'm going to use a scale of 1 here. So at -6, we're up at +6. And then +4, +2, 0, 0, +2, 4, 6. So what we see is this kind of V shape coming through. Not even kind of. It's a V shape. We see this V coming through. So from the origin, we have this straight line going out in a positive direction, and going towards the origin, the negative slope, we have these two lines that connect to make the absolute value function. And this idea, you have this behavior of plugging in values and you only get positive outcomes. So you're going to either be completely above the x-axis or completely below with this form here. So they're on the same side of the axis there. And then you have this corner. And in this case, the corner that we're seeing is 0, 0. So the structure of your absolute value function, and we'll start to see some kind of transformations of it, like what if we change how it's stretched out, or what if we change where the corner is landing. So we can move this V shape anywhere onto the grid and change the shape of it, but there are certain characteristics that always hold. So things that we'll look for is the corner. The corner will be an important piece. We'll talk about how it opens upward, or we could see an absolute value function that opens downward. That's a possibility. And then what we can see is a change in slope. So for this graph, what we can see is on the left-hand side here, there's this slope of -1 occurring. So over here we see the slope of -1, and then over here we can see a slope of +1. Move right 1, up 1. So over here, a slope of +1. What the absolute value functions that we're going to look at will see this same slope. It's just one's going to be negative and one's going to be positive. It isn't always negative on the left, positive on the right. It could switch around, especially when it's opening downward. You could see it's positive, then negative. So, but it's something that we'll look at in terms of helping us make our equation. So we're going to focus on, in the graphs, looking at slope and looking at the corner and seeing how that can make up our absolute value function. Our last piece here, let's talk about the domain and range. So for the domain, what we can see is that we can plug in absolutely anything for x. That's not limited in any way. So our domain is going to be all real numbers. So -infinity to +infinity. Then for the range, we are limited with the range because we can only have certain outputs, and it's coming from this restriction that if we're plugging in negative values, they're going to turn positive. So it's restricting the values that we can see as possible outcomes. So it starts at the corner, and that's going to hold true for other graphs as well after we look at some transformations. And in this case, it starts at the corner and then goes off to +infinity. And we include the corner since that's a defined point. So our range is starting at 0 and including 0, and then goes off to +infinity. So with absolute value functions, you're going to see this V shape. It's made up of these slopes, negative and positive. You have this corner. The domain will be all real numbers, but the range is going to be limited with where that corner is occurring.